Any highlights in case you don't know Booking.com. We are a leading e-commerce travel company. So the company is actually founded in Amsterdam in 1996. It is a Dutch startup. Right now, though, we have around more than 17,000 employees in like probably 100 different countries. And this is a snapshot from Rembrandт Lane. If you guys are here for the first time in Amsterdam, you can go there. And right now, we have more than 1.5 million room nights being booked every day. So one thing we do have the luxury of here is data. And the journey and the talk is going to be how do we leverage that for insights. And of course, our company mission is like how we experience the world and enabling others to do them. And for today, I'm specifically going to talk about search in Booking.com because when I joined, mostly I have been working on search, and I'm going to focus on how we specifically use machine learning to solve problems related to search. So just to give some insights in terms of what people search in Booking.com and what I mean. So yeah, you go to Booking.com and you can search for any cities in the world, any landmarks, any address, of course hotels and homes to stay. But if you look at like what are this kind of stuff people actually search for, you might have some fun. So people are actually searching for Batman there because apparently there is an airport in Turkey which is called Batman. So that's kind of fun. But just to go back to our talk today, what I'm going to focus on specific to this autocomplete search. When you're typing for something, how do you actually match the results and how do you show the best results and how you can add value for the users. So let's say today we are in Rai in Amsterdam and you want to search for hotels, let's say near Amsterdam. Right, so you start searching. So you type AMS and you don't find Rai in the top 5 results that we are showing. So as a user, you probably keep typing. That's it, you have found it, and then you go ahead happy and hopefully book a hotel with us. So this is the part that I want to focus on today. And before we even go there, so let's say I joined the company around 2 years back. I want to use machine learning to improve this search ranking. But in Booking.com, we really follow this as closely as we can, keeping our customers in front of everything that we do. So what does that mean for us, even before we starting off with this project, like using machine learning for search, right? It's sort of asking very tough questions like this. Should we even have our own search team, which needs, because our competition is right over there, and they do pretty not so bad job at it. So how do we even fund this kind of efforts, or how do we even go about convincing leadership teams of using machine learning for our own search engine? So another interesting thing about Booking.com is most of the questions that we try to find answers for, we just run experiments and let data tell us about what is the right thing to do. And this feedback loop that you see there, that's like our holy Bible that we do sort of in every product development that we do. How do you have a question, you have an hypothesis, run that as a test, find out what happened with user data, user behavior for the business, and how can you learn from that and iterate. So in this case, of course, you can do that only if you have lots of data, and then thankfully for at least in a scale of Booking.com, we do have the luxury of that. So the question still remains, should we use our own search engine or should we use Google Places API? Because that's a pretty not bad alternative. So we actually ran a test, and just to prove okay, what value are we adding. And these are the summary of the results. Like immediately within a few time, because we have large enough traffic, we can see the drop in business metrics, we can see the drop in search metrics. So we decided, great, so we do have something to work with here, and we can probably make more value here. Another question, okay, great. So our search is better than Google Places for our travel spaces. So how do we even like effort, how do we invest effort that, you know, if we improve search ranking, it will actually add some value for our users. Maybe it's already the best out there. Or does it even matter? Maybe the user wants to search for something and they will eventually find it. They can keep on typing, maybe it will come up. So how important is ranking really for our users? So how do we find that? This is also another technique that you can use for any ranking. Before even investing an effort, if you want to find out, okay, what's the impact for our users for a ranked list, you can do a simple test by just randomizing the results and see whether that actually deteriorates the user experience. So we did same test, our base experiment being our smart ranking algorithm, and we have variant randomized results. Let's see what happens. So yeah, that actually matters as well. So users did see a drop in business impact. The click-through rates dropped, which also told us, okay, there is some potential in going forward with our search ranking efforts. So going back to what are the problems really we want to solve for search, right? If you look at very basics of information retrieval, it goes back to these two key metrics. So when you have a search engine, you want to improve your recall, which means that if something is out there, the user is trying to find that, it's better to show that to the user. And the accuracy of the results that you show. You can always show some junk, but that's not going to play well with our users, right? So how do you improve our precision of the results? So in Booking.com context, what these mean for us, some example. When you say recall, so for example, user is typing, let's say, Paris, and there is a spelling mistake. So in this case, you do see that Paris is showing up, but this was before when, let's say, there was no zero results. That would be a really, really bad user experience for us, and we don't want that to happen. So how do we how do we see what are the searches that's leading to zero results? How can we improve that component of the ranking? Similarly, for precision, what the questions that we're really asking is like when you're typing and you see these 5 results, how often are you clicking on the first result? Because we, of course, want you to show the best result at the top, right? So what are those search queries we can monitor from our logs that is not happening, that users are clicking maybe Dubrovnik or Dublin Airport in this case? And how do we learn from that? How do we improve our precision on this ranking? So now finally the part where, okay, we have some proof that it actually matters to us. We have convinced everybody, stakeholders, that, okay, let's go for it. Let's use some machine learning to improve. How do we go about doing that? So one part is, of course, we can use very sophisticated models like learning to rank model and apply them. But even before doing that, can you do something very simple? Like I said, of course, we have millions of anonymized search traffic every day. And there are so many user insights in those search data that can most often solve most of the problems that we are trying to solve here. So let's look at one example. So we have the initial problem, like how do we want to solve for recall? So consider this scenario where we don't have any spell checks right now. What happens for the user? You come, you start typing. You don't see any results. And some of them, of course, will leave the website, they will bounce. But some of them might still want to stay with us and realize that, hey, there is a typo. So I'll go ahead and correct myself. The users are smart enough. They go and they realize this is happening. So they next time search for Paris, and voila, you have the results now. Now, just looking at this whole search traffic and the sequence of events, next time when somebody does the same mistake, I can just learn from that simple data and go back and show them that, hey, if you start typing for this, maybe you're looking for Paris, and we already know that from the data. I don't even need any edit distance based model or anything like that. So that is successful, improving in terms of recall. And similarly, for precision. Here, if you see, the question is about ranking. We want to show the best relevant results at the top. So consider user is searching for something like York. Now, we know that New York is, of course, most booked hotels, or other than the other results, so globally that's more popular. But when we look at and zero down and try to look at contextually, when user is typing York, what are the results that they're clicking on? And turns out New York is not so relevant anymore. Users are actually clicking on York or Yorkshire in UK, for example. So how do we translate that signal back to the data? So that's what we did. We actually set up this whole user logging, looking at all the data that you were typing, what you were clicking, and actually adding this as a signal back to our search ranking algorithm. And right now, we just started off with using very simple probabilistic statistical learning models using naive-Bayes approach. We did not even go to learning to rank yet. But this itself added so much value in itself. So we wanted to follow up on this further. The key learnings 2 front, I think that can be takeaways for us. One was if you have the luxury of so much data in an e-commerce platform, please do use them. They are often easiest way to crack some of these problems even before applying any other sophisticated machine learning algorithms. And also another problem for us was, I mentioned the question came up about language before as well. So we do have our website available for 43 different languages. So if you want to use some of the NLP techniques to solve for different languages, they're still not that sophisticated for other language as opposed to English. So we do have that barrier there. But if you're using the user data, you don't really have to bother about language anymore because you have traffic from all languages and you can see the same behavior being out there in all languages, and you can just let users help the next guy who comes in. Having said that, the challenge that still remains is how do you go around the self-fulfilling prophecy, because if you start showing something and if it gets more and more clicks, they will keep showing up in the top. So that's something that we are still trying to solve, like, okay, how do you do explore exploit, or how do you provide for new results to surface? How do you deal with this problem? To final summarize, of course, like for me, my journey in booking have been how to use data science in product. But at the same time, even using machine learning, I can still apply the same principle for product development where you do experiments, you validate your thoughts, learn from those metrics, and then go ahead and iterate with your approach. Thank you. If you have any questions. Sure.
Hi, thank you very much for your talk. That was very insightful. My name is Manos Tsagias from 904 Labs. We do AI for search, especially for e-commerce. We have talked with people at Booking before, but I have a couple of questions for your talk, which I found very interesting.
Sure.
The first one is, when you did the two A/B tests, one with the Google Places and the other one, the raw numbers, they were very small. So, for example, it was less than 1%, perhaps, if I recall correctly. Did you have a certain threshold that you had predefined before, above which you would say, all right, this is worth pursuing? Or
so I can answer that question. So for us, even if you see 1% drop in conversion, given that we have like millions of traffic per day, that translates into like a huge revenue stream that you would be losing. So even a drop in 1% conversion is like really, really huge. Most of our optimizing experiment would be doing like 0.1% uplift or something. Okay. So having a bad breaking like 1% conversion is actually like an outage for us. So,
oh wow, all right, okay, good to know. Thanks for that. My second question is with regards to your autocomplete experiments and your other learning to rank, well, not learning to rank, but machine learning based experiments. Have you run A/B tests for that? Is that some conversion rates uplifts that perhaps you could share with us?
Sure, of course. So each of these things that we improved, they eventually went full on because they were uplifting conversion behavior as well as the search metrics. And that's why we pursued. We did try learning to rank as well. There was a problem that did not succeed because right now the way you train those models had a lot of biases in the data. So you're still going to follow up on those approaches, but of course these models got succeeded both in terms of business metrics and search metrics.
So we can think that was in the range of 1% plus this time?
Not exactly, I would say, but exact numbers I can talk to you offline. Okay. But yeah, of course they improved the user experience a lot.
Thank you very much.
Yeah, thank you.
Hello, thank you for the report. I'm Taras from marketing agency called Cicero. For me, Booking.com is very different from all other websites because a lot of notifications, a lot of tips. It is the last hotel, and so many, really different from all other sites. I know. And is it also you using machine learning for all these tips? Or just like usual ideas, A/B testing, or some machine learning here? Can you a little bit speak about it?
So the parts that you were talking about, we call them internally like various persuasion messages, and they have been there because they have successfully worked in the past for improving business metrics for the most part. But we do have a lot of efforts going on right now, where we are trying to use machine learning to identify segments and trying to make these messages a lot more contextual. So instead of like bombarding everyone with the same kind of messages, we are trying to learn what are the users interacting with these messages, each of these components, and trying to train our model so that maybe show the most relevant messages for the most relevant segments instead of just like creating this whole blob of stuff that's going around. Especially because I think the website have been really like been there from 1996, so you can imagine all of this is a byproduct of the legacy that we have. And compared to our, let's say, more recent competitors, you have a very fresher or very different kind of web experience or user experience that they offer. So how do we sort of bridge that gap, or how much value that actually translates in terms of business value? That's something we constantly monitor and do try to optimize.
Thank you.
Hi. I would like to ask a question as a user of Booking.com. It is obvious that you guys have like an army of IT people in Amsterdam. I know for a fact you have buildings everywhere in the city, so I assume you have a lot of people working behind laptops and computers or whatever. What I would like to know actually is, if that's so, why I still get from Booking.com push messages and advertising, promotions, messages about a destination I just came back from?
That's probably one of the most common bug reports we do get, and I assure you there is a team that's trying to fix that as soon as possible. Thank you. But thanks for your feedback, honestly.
Hi, thanks for your talk.
Thank you.
Can you maybe talk a little bit about the experimentation framework that you guys have? From, let's say, a point that you as data scientists have a model until the time it goes to production, and how do you make sure that, for example, experiments don't overlap or interfere with each other?
So, two parts to that question. I tackle the second part, which is applicable not just for machine learning experiments, but for any experiments you speak. So because, let's say, on an average, we have millions of traffic, the basic assumption is we randomize a randomized trial. So each experiment ideally should be independent of each other. And if you, let's say, two experiments that's running at the same time, the second experiment should be equally distributed in your base and variant, because you do 50-50 traffic and you're continuously doing a coin toss. So it should be randomized, and we do see that. If in case you're working on the same part of the product, let's say you are trying to optimize this ranking in some way and somebody else is trying to do something, of course there is going to be a conflict. So two ways we try to mitigate that. One is in the experimentation tool that we have. There is a way to flag those as errors or conflicts, etc. Based on traffic overlap, behavior overlap, those kind of things. And of course the other more, I think, practical is just communicating with other teams. There are like really like probably 10 teams working on different parts of the similar parts of the website. So unless we do try to catch up regularly, weekly basis, collaborate with each other, inform upfront that, hey, we guys want to work on this for the next quarter, or stuff like that. Coming back to your first question, for machine learning models, of course, we do have an in-house platform as well, where you sort of train your models, then try to test those models just to see how they perform offline versus online, and then make them available in the in-house platform for everybody else to use. So some of these machine learning models are worked closely together to a particular product, but some of them also are independently worked upon, which can be used for anyone. Like anyone can go to the platform, see what features they are using, how did they perform, how can I apply that model to solve a product. So it's both ways we try to work together. And of course, like even if you're using that model, eventually we do monitor the experiments that if it's breaking something, even if you think, because a lot of times it need not be the fault of the model, it can be something else that's breaking behind, right? So we always monitor the experiments once we're starting.
Hi, you said that all searches are anonymized, right? So so you don't distinguish between different users, right? Yeah. So, but making typos is almost like a digital signature of a person. It depends on geometry of the hands and the keyboard that you have, and I got myself always making same typos, and. So have you thought that you might actually want to make it, usually people get logged into site already, because these kind of things could be very dependent on person to person, and do a little bit of, transitional learning maybe for the personal part, and maybe improve that way.
Sure. So it's a very valid point that we do have those individual intricacies as well. What we did see though, because we started from a very basic, by just targeting different user segments itself had so much value to uncover that we haven't yet reached that personalization at a user level. The other thing is also, it's not like any other e-commerce where you travel that frequently, or you buy products like in Amazon more often than you're buying a hotel, for example. So we don't have that much recency in terms of people coming back immediately. The other part is also in terms of typos specifically, the interesting thing that we did see though, people have very different typing behavior in desktop platforms versus on their phones. And what happened for that particular experiment itself is when we trained the model using the desktop data, it went live for desktop, which is great. The same thing when we tried for mobile, it did not succeed. And the reason when we were trying to dig through that and learn from it, one of the ideas just came up randomly. Hey, maybe the typing is behavior different because you are using swiping keyboard or something else. So we then separately trained the model for mobile data and apps data, and then that went for on. So we do see these kind of intricacies being there in the data. But the value for us right now is aggregating them rather than individually, because also the data gets sparse. That's the other problem. So, but hopefully we can get there eventually.